Hello students, welcome back to your YouTube channel Mathematics for Everyone. In this video, we shall take inverse trigonometric functions of class 12 mathematics. First of all, in inverse trigonometry, we shall also take principal value of the function, definition of trigonometric functions, and their properties. So first of all, we write principal value of the function. Principal value of the function. The smallest numerical value, the smallest numerical value the smallest numerical value, either positive or negative, either positive or negative, of angle theta is called the principal value of, is called the principal value of, principal value of trigonometric function, of trigonometric function. The value of the inverse trigonometric function, the value of the inverse trigonometric function, value of the inverse trigonometric function which lies in the range of, which lies in the range of, in the range of principal branch, principal branch is its principal value, is its principal value. Whenever no branch, whenever no branch of an inverse trigonometric function, inverse trigonometric function is mentioned, whenever no branch of an inverse trigonometric function, we mean the principal value branch. We mean the principal value branch. Value branch. Now, we shall define inverse trigonometric functions. We shall define inverse trigonometric functions. Inverse trigonometric function. Number one, inverse sine function. Inverse trigonometric function, inverse sine function denoted by sine inverse x is defined as y is equal to sine inverse x if x is equal to sine y. For all x belongs to closed interval 1 1 and y belongs to closed interval minus pi by 2 to pi by 2, which is the principal value branch, which is the principal value branch or range of sine inverse x. Second, inverse cosine function. Inverse cosine function. The inverse cosine function, denoted by cos inverse x is defined as y is equal to cos inverse x if x is equal to cos y for all x belonging to closed interval minus 1 to 1, y belonging to closed interval 0 to pi, which is the principal value branch or range of cos inverse x. Third, inverse tangent function. Third, inverse tangent function. The inverse tangent function denoted by tan inverse x is defined as y is equal to tan inverse x if x is equal to tan y for all x belonging to real number r and y belonging to open interval minus pi by 2 to pi by 2, which is the principal value branch, of or range of tan inverse x. Fourth is inverse cotangent function. Inverse cotangent function. The inverse cotangent function denoted by cot inverse x is defined as y is equal to cot inverse x if x is equal to cot y for all x belonging to real numbers and y belongs to open interval 0 to pi, which is the principal value branch or range of cot inverse x. Fourth is inverse secant function. Fifth is inverse secant function. The inverse secant function denoted by secant inverse x is defined as y is equal to secant inverse x if x is equal to secant y for all x belonging to r minus open interval minus 1 to 1 and y belonging to open interval 0 to pi minus set pi by 2, which is the principal value branch or range of secant function secant inverse x. Six is the inverse cosecant function. Inverse cosecant function. The inverse cosecant function denoted by cosec inverse x is defined as y is equal to cosec inverse x if y is equal to if x is equal to cosec y for all x belonging to r minus open interval minus 1 to 1 y belonging to closed interval minus pi by 2 to pi by 2 excluding 0. Here is also y belonging to closed interval 0 to pi, which is the principal value branch or range of cosecant inverse x. Now we take, so these are the definitions of 6 inverse trigonometric functions. Now we shall take some properties of trigonometric function. Properties of inverse trigonometric function. Trigonometric functions. Number 1. Sin inverse sin x is x for all x belongs to minus pi by 2 to pi by 2 closed interval. Cos inverse cos x is equal to x for all x belonging to closed interval 0 to pi. Tan inverse tan x is equal to x for all x belonging to open interval minus pi by 2 to pi by 2. Cot inverse cot x is equal to x for all x belonging to open interval 0 to pi. Secant inverse secant x is x for all x belonging to closed interval 0 to pi minus set pi by 2. Cosecant inverse cosecant x is x for all x belonging to closed interval minus pi by 2 to pi by 2 excluding 0. Second property, sine of sine inverse x is x for all x belonging to minus 1 to 1 closed interval cos of cos inverse x is equal to x for all x belonging to closed interval minus 1 to 1. Tan of tan inverse x is x for all x belonging to real numbers. Cot of cot inverse x is x for all x belonging to real numbers. Then secant of secant inverse x is x for all x belonging to r minus open interval minus 1 to 1. Cosecant of cosecant inverse x is x for all x belonging to r minus open interval minus 1 to 1. Third property, sine inverse x 1 over x. Sine inverse 1 over x is equal to cosecant x for all x belonging to r minus open interval 1, 1. Proof, let sine inverse 1 over x is equal to y, this is number 1. By definition, 1 over x is sine y, x is cosecant y, again by definition cosecant inverse x is equal to y. This is second. From first and second, sine inverse 1 over x is equal to cosecant inverse x. Similarly, cosecant inverse 1 over x is equal to secant inverse x. For all x belonging to R minus open interval minus 1 to 1. Then tan inverse 1 over x is equal to cot inverse x. For all x greater than 0 is equal to minus pi plus cot inverse x for all x less than 0. Then next, fourth property, sine inverse minus x is equal to minus sine inverse x. Proof, let sine inverse minus x is equal to y. This is number 1. By definition, minus x is sine y, x is equal to minus sine y, x is sine minus y. By definition again, sine inverse x is equal to minus y, minus sine inverse x is equal to y. This is number 2. From first and second, sine inverse minus x is equal to minus sine inverse x. Then, similarly, we have cos inverse minus x is equal to pi minus cos inverse x. Pi minus cos inverse x for all x belonging to minus 1 to 1. Here also, for all x belonging to minus 1 to 1 close interval. Proof, let cos inverse minus x is equal to y. Number 1, by definition, minus x is cos y, cos is equal to x is equal to minus cos y, which is cos pi minus y. Again, by definition, cos inverse x is equal to pi minus y. Then y is equal to pi minus cos inverse x. This is second. From first and second, we have cos inverse minus x is equal to pi minus cos inverse x. Then, similarly, tan inverse minus x is minus tan inverse x for all x belonging to real numbers. Then, cot inverse minus x is equal to pi minus cot inverse x. Similarly, we can prove that for all x belonging to real numbers. Secant inverse minus x is pi minus secant inverse x. For all x belonging to R minus R is set of real minus open interval 1 to 1. Cosecant inverse minus x is equal to minus cosecant inverse x for all x belonging to R minus open interval minus 1 to 1. That's all. We have taken some formulas, 4 formulas in this video. We shall take 4 properties. We shall also take more properties in next video and also take the question relating to inverse trigonometric function. So that's all. Please don't forget to like, share, comment and subscribe to your YouTube channel Mathematics for Everyone to see more important videos. Thank you. See you in the next video.